Okay, welcome everybody. Thanks for coming. This is the last webinar of the entire class. So we're pretty close to being done. We still have chapter 13 to go on and some other stuff. So let me tell you the plan. As always, I'll be answering any questions. If you have any questions, I'll be happy to answer questions throughout. Could be about the content we're doing, could be about other stuff too. So I'll be watching the chat box and you know, check in if you have questions. Also listening. So then after that, we're going to get into something called ANOVA. ANOVA turns out to be actually used a lot, but we're not going to get into the details because this is elementary statistics. So I'm just going to show you how to use ANOVA and some of the requirements, but not all the different things and the advanced parts of ANOVA and all that. We're just going to do ANOVA. And we'll talk about, what the H naught and H1 are. We'll also talk about after that what the requirements are. So what you have to have being true to be able to conduct an ANOVA test. Okay. And as I mentioned weeks ago, um, we're at the end of the class. We've been doing hypothesis testing pretty much every week for a while, and this is another hypothesis test. So there will be requirements to be able to use this test. I'll talk about that. Then I'll talk about project two. Project two is due on Sunday. Okay, I recommend having it turned in by Saturday so you don't like be rushing at the end because that always helps to try to get a little bit early. You don't have to finish it super early, but don't wait till the last minute because that's when your internet can die and then all of a sudden you don't have it done. I do want to mention that the drafts, if you want me to read the draft, and that helps a lot, and you haven't already sent me the draft, then you have to send it by Thursday at 8 a.m., but better would be like by Wednesday, when's not too late, because then I read it on the first submitted, first read basis, and they all get sent in on Thursday morning. It could be Saturday before I get back to you. And I actually have a busy Friday, just to let you know. So it is very important that you do that, and it helps a lot. I'll talk about Project Two and some of the things that I've already noticed that people have done that can be improved on, and just things that in the past that I've noticed too. I'll also talk about the end of the class. We're at the end. Again, this is the last webinar. We're going to be chapter 13 today, and that's the last chapter of the whole book. Of the whole class. We're pretty much finishing off. So by the end of this webinar, you'll have heard everything there is to know about elementary statistics. I do want to mention a few more things. One is that this is week 11. It's an odd week, and I always make sure that the projects are doing odd weeks. Otherwise, it's too stressful to try and do the project and the exam. So there's no exam, but there will be an exam next week. But next week's exam is not the whole week because we're done on Wednesday. So you have to have it by the end of the day on Wednesday for the exam due on for the final exam for the class. Just let you know. And then the course is over. So after Wednesday, that's it. So that is the plan for today. I expect this to not take as long as usual. We're just doing one chapter and it's not that hard a chapter, it's not that long a chapter, but always after I'll be happy to answer any questions you have throughout. Whatever questions, they could be long questions, that's fine too. And I'll do my best and talk to you, about whatever you have questions on. Are there any questions now that you have questions about? Anything? I'll be happy to answer anything. If not, we can move on. Okay, let's think about what we have already done. Again, that's the whole course until chapter 13. So we started out in terms of hypothesis testing. We looked at a mean, we looked at a proportion. Then we went to two means and two proportions, if you remember. That was chapter 10. And then we looked at when you had qualitative data And that could be several proportions comparing all of them. And it could be just regular qualitative data too, and distributions. And then we did regression analysis. What haven't we done yet in terms of um, what there is to do? The question is when does the final? Oh, good, you got it. I'm trying to remember, but I think it might be Wednesday. But you have plenty of time to do the final. So at least a week ahead of time. Might be now already. Yeah, so okay. So what haven't we done yet? What have we not learned how to hypothesis test about? Any thoughts? It is open right now. Okay, so the final is open. But I don't even touch the final until you've done chapter 13 because a big portion of the final is chapter 13. So you don't want to be doing it before you've learned chapter 13. So that's really important. So just a note for the final. And this final exam isn't worth any more than the regular exams, the weeks, even week exams that you had. So it's not super high stakes, but it's still important. Okay, so what have we not learned how to do a hypothesis test about? What kind of hypothesis test don't we know how to do? Again, we know a mean, we know two means, we know a proportion, we know two proportions, we know several qualitative data. What haven't we done yet? Any thoughts? So mean with proportions, I'm not sure what that would actually entail because you don't compare a mean and a proportion because that would be weird. So of course we haven't done anything that you would never want to do. Okay, no thoughts, let me tell you. So the one thing that we haven't done, as soon as I say it, you'll say of course, and that is finding out if you have, let's say, three or four different means you want to find out if they're all the same. Or maybe there's a difference by at least one of them. Okay, maybe at least two of them are different from each other. So we haven't learned how to do that. We've compared two, but what if you had three means? So that's what we're going to be doing now. And this is a little confusing. It's called analysis of variance. And I'm always going to be calling it ANOVA because I think the words analysis of variance is confusing. I will tell you, but I'm not going to explain it at all. The reason why it's called analysis of variance is the deep mathematics behind it is about variance, but not anything that we're going to be doing because we're not doing the deep mathematics behind it. We're just going to be using the test. So it tests to see if several population means are equal or not. Okay, so if you have maybe a bunch of means and you want to find out if they're all the same. So just let you know, and this is important, and in the webinars, when I say it, you have to do it. So you're going to have an H naught and an H1. And unlike the other hypothesis tests, they're not both the same. H naught will be in symbols. Mu1 equals mu2 equals mu3 equals mu4, all the way to the last one. Okay, if there were just three different means you're comparing, mu1 equals mu2 equals mu3. If there were 1,000, you would go mu1 equals mu2 equals mu3, and you go dot 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 equals mu 1,000. And that says they're all the same. Okay, to let you know that the opposite of them all being the same is not that they're all different from each other. That's why you can't just take these equals and make not equals. That doesn't work. So instead, what you need to do is put it in words, and the words are at least two of the population means differ from each other. Okay, so that's H1. And you should say what the means are. So it might be that at least two of the population mean, heights differ from each other. You should definitely address what it is. So this is in general, this is a template, and it is important that you use the template. So H naught is going to be in symbols, H1 will be in words, and you will lose points if you don't do that. Any questions on that? I'll show you examples too, of course. Okay. And just note, you don't have to use Greek letters written like this on the exam, for example, because some of you have trouble with the tech, and that's okay. If you want to use like for the second one, you can use mu and then a little underscore two, and that's the second mean. So it'd be mu sub one equals mu sub two equals mu sub three, but then mu instead of the Greek letter. I'll let you do it that way. If you were doing this for, some kind of published paper, you'd want to do it with the Greek letters. Okay. Then the requirements. And some of the requirements we've already seen. Okay. So one of the requirements is all the sampling distributions must be approximately normal to be able to make this happen. What do you need in our class to ensure that you have approximate normality? What do you need? Do you remember? We've talked about this before. So you don't have to assume approximate normality, but you know that you have approximate normality. Remembers? We've said this many times. Don't see Al jumping in. You have to make sure the sample sizes are all bigger than 30. Remember that? That was part of the central limit theorem. If you have a sample size bigger than 30, then the sampling distributions are approximately normal. So if you happen to have the sampling distributions bigger than 30, you don't have to assume that all the distributions are normal. If you don't have a sample size is big enough for each of them, then you have to assume they're approximately normal. And assuming is a bad thing, but you know, you have to in our class. But in the real world, that's a bad idea. Okay. And that means you can end up with a giant, giant data set. For example, let's suppose you wanted to find out if the average height is the same for every state in America. Okay. And by the way, I have no idea if the average height is the same or not. My guess is there might be some differences, but I really don't know. But if you want to do a test, that would be ANOVA. And you would have, there's 50 states in the United States. So each state you would have to have over 30. And that is at least 1,530 as your total sample size. Because 31 times 50 is a big number. So it's a lot of work if you have a large group, a whole lot of groups. If you only have three groups, it's not so bad, but when it's a lot of groups, it's hard. Okay, another is that all the population standard deviations are equal. Um, what we're not doing in this class is learning how to tell if they're equal or not, or approximately equal is good enough, actually. But that is beyond this class. And since this is our last webinar, I will tell you that that's something you would get in an advanced class. And this is not advanced statistics, this is elementary statistics. So what you should just know is you have to have it being true. What you don't need to know in this class is how do you know if it's true? Okay. You have to have, and this is something we've done for everything we've done for the whole class, is that anytime you do a hypothesis test, you have to make sure you don't have bias. So if you have a bias survey, then you have worthless data. So kind of simple random sampling or close enough to it. So no bias is important. Okay, the samples are independent of each other. Turns out if they're dependent, then there's other tests you can do, but we can't do that. We don't have enough time in this class. So we're in our last day, so we're just going to do ANOVA. So I will let you know there are a lot of other statistical tests besides what we've done. Don't think that since you've taken this class, you know everything there is to know about statistics, but you know the basics. Okay, if you pass, you know it. So the samples have to be independent of each other. Okay, which is often not a problem. Okay, but you just got to make sure. And then you have to make sure the samples are consistently taken. So that's a biggie where let's say you're surveying different, let's say you're doing the one I suggested, which is if you look at the states in America and you want to find out the heights are the same or not, you have to make sure that, the way you're surveying people is the way you're measuring heights should be kind of the same for everyone. So you don't have weird ways of doing it. Okay. So you should be consistently taking the samples. Okay. So it's a lot of requirements. I can't get into all the details, but just the ideas. Any questions on the requirements for ANOVA? Any questions? Okay, ANOVA does happen in research a lot. It doesn't happen in day-to-day life, but it does happen in many, many research papers. So just be ready for it. When you get into your upper division classes, it does come up. Okay. And I will let you know that there's different types of ANOVA. We're doing what's called one-way ANOVA. And it's the hypotheses are what I showed you. So there's a two-way ANOVA, there's multi-way ANOVA, but that's again advanced stats, and we're not doing advanced stats in this class. So I do want to give you the heads up is that we're just doing the basics of ANOVA. Okay, let's look at an example. Okay, so here's the example. Okay, suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. The data from the study are shown below. So, for example, by the way, see if you can type in the chat box. How many miles do you live from the nearest public library? I live 2 miles from the nearest public library, by the way. How many miles do you live from the nearest public library? Do your best guess. Okay, it's a very easy survey question. Not everyone knows. Okay, so different amount of miles. Really depends on, kind of where you live. And I will let you know I made up these numbers, but you can imagine a surveying being done. And I just put a bunch of numbers in here. Um, so what assumptions must you make in order to perform a ANOVA test? So here we got, again, we asked these people, and what we're looking at is racial differences. We're looking at whites, blacks, Hispanics, and other races. And let's look at the assumptions. And I'm just going to basically list the 5 assumptions and think about whether we really need it. Okay, must we assume we have approximate normality? How come? Why must we assume we have approximate normality? What do you notice about this study? So why must we assume we have approximate normality for each of the racial groups? And that's each of the racial groups' distance from the library. So why must that assumption be made? See y'all jumping in. It should be obvious. Okay. I don't see anyone chatting in. It's pretty clear why we have to assume normality for each of the racial groups. No ideas? Look at the sample sizes. For the whites, we had a sample size of 6. For the blacks, we have a sample size of 4. For the Hispanics, we have a sample size of 6. And for the others, we have a sample size of 4. All the sample sizes are not, they're below 31. So we have to assume we have a normal distribution for all of them. Otherwise, ANOVA can't be used. Is that clear? None of you said that, but hopefully you understand it. That's just whenever you want to check for normal distribution, you usually are checking for sample size. Okay. And by the way, even if the total sample size of all of it, if there were 31 numbers there, that's not enough. It has to be at least 31 for each group. And let's say Hispanics, we surveyed 35, but all the others we surveyed, as you see, then you would have to assume normality for whites, blacks, others, but you wouldn't have to for Hispanics. Any questions on that? But in this case, they're all, small samples. So we have to assume normality for each of the racial groups. Okay. We have to assume the population standard deviations are equal because nowhere in here do we have any idea whether they're equal or not. So we have to make that assumption. Yeah, so as long as it's above 30, you have approximate normal distribution. Hopefully you remember that's called the central limit theorem. Okay. So central limit theorem is if you have an unbiased study with above 30 and you look at the sampling distribution, you always have a normal distribution of the sampling distribution. Okay, so standard deviations are equal. Again, we have no reason to like see that they are equal, so we have to assume they're equal. Okay, and then we have to assume there was no bias. We had simple random sampling with no bias. And that again, it just says a study was done. It doesn't talk about how the study was done. So we need to make assumption because we don't know anything. Okay, and then the samples are independent. It's probably not an issue that's independent. Okay, it'd be actually kind of hard to do a study of not independence with, surveying whites, blacks, Hispanics, and others, how far they live from the nearest public library. So, although you kind of have to assume it's probably true. If you happen to know a little more about the study, you would say, yep, the independence isn't a problem. This particular type. Kind of issues of independence would be if you're looking at, maybe a bunch of siblings and seeing some survey question that you asked of all the siblings, that would be dependent. Or if you ask one person 7 questions and then you ask the next person 7 questions and the next and the next and the next and the next, then they would be dependent. That makes sense? But here, they're probably independent, but it doesn't say. The samples were consistently taken. Also, most likely true. Maybe not, but, you know, probably true, but it may not be. So you have to assume it. Any questions on the assumptions? Okay, so here we're testing to see if the means, the population mean distance from the library is the same for each of these 4 racial groups. And to do that, we have to perform an ANOVA test. Okay, so let's write down the H naught and H1. So H naught, you do H naught colon. Hopefully you're used to that because that's pretty much all hypothesis tests. And what I'm going to write is mu sub W. So that's the population mean distance from the nearest public library that whites live in is equal to mu sub B. That's the population mean distance from the nearest public library that blacks live in from. They're equal to mu sub H. That's the population mean distance from the nearest public library that Hispanics live from is equal to mu sub O, and that is the population mean distance from the nearest public library that groups from other races live from. Any questions on H naught? Okay, if you know what to do, it's pretty easy. Okay, and then for H1, at least 2 of the races' population mean distance from the nearest public library different. So notice I took the template, at least 2 of the population mean differs from each other. And I made sure I also referred to race and distance from the nearest public library. Okay, so I took the template but put in the context, and that's something you have to do. Okay, don't just use the template, you got to put in the context too. Any questions on that? Okay, and that will be a requirement on the final exam, by the way. Any questions? Okay, what do you think the next step would be? What's the next thing you have to do? Any thoughts? We've done this lots. This is not new to the class. What's the next step? Don't see y'all jumping in. The next step is to decide on the level of significance. And in this case, this is a sociology kind of thing, and sociologists almost always use 5% level of significance. So let's use 5% because you're doing a sociology thing. If you look at, type 1 and type 2 errors, but really it's a sociology, so it's clearly just 5%. So you use a 5% level of significance. And what's after that? What do you do after that? What's next? Hopefully you all know because it's a step-by-step that we've been doing all class for the last bunch of weeks. The ramifications were to decide on the level of significance. And here the ramifications is sociology based. I didn't get into the details, but so I used a 5% level of significance. So it's just the ramifications is, we, didn't quite understand the social characteristics. Is we thought there was a difference in distance from the nearest public library, and you're gonna, look at that and publish that in the sociology journal versus not seeing any significant difference. Publish that in the sociology journal. So either way, about the same, so we just say 5%. So what's the next step after that? You should all know. Let's see, jumping in. We find the p-value. That's always the next step after you've chosen your level of significance. How do we find the p-value in the test statistic and p-value? Any thoughts? Here's our data, by the way. How do we find the test statistic and the p-value? Yeah, go to the calculator. Okay, you go to the calculator. Just to know, if I go to the calculator, guess which calculator number we're going to use, and it'll make you smile, hopefully. Yeah, we're done. This is the last. This is the last thing of the entire course is ANOVA. Okay, and the way I coded this is data one, data two, data three, data four, data five, etc. So data one will be 15, 4, 11, 9, 3, 2. So 15, 4, 11, 9, 3, 2. And then data 2 will be 12, 1, 6, 6. 12, 1, 6, 6. Data 3 will be 9, 17, 5, 14, 7, 1. 9, 17, 5. Oops, 5. Let me read it again. 9, 17, 5, 14, 7, 1. And data 4, 18, 11, 2, 8. Any questions on using this calculator? Okay. Now I just scroll down, I hit calculate. It's very simple. And here we are. And this is something you've never seen before. This is called the F distribution. This is not the grade, by the way. This is called the F distribution. And in fact, it might be helpful to take a look at the F distribution. I think I have it. I'm trying to remember. It's been a while. So we want the ANOVA somewhere in here. There we go. So here's the F distribution. Turns out there's a numerator degrees of freedom and denominator degrees of freedom. I'm not going to get into the mathematics behind it all. There's two sets of degrees of freedom, and changing it changes the distribution shape a little bit. Notice it is skewed a bit to the right. Notice also that it's not a normal distribution. It's skewed to the right. You don't get any negatives. So Z is with proportion and t-test with mean. ANOVA use F. Yep. And then for like goodness of fit, use chi-squared, remember? And homogeneity is also chi-squared and independence is chi-squared. Yep. So there's a lot of different distributions. And those are the most common. So in our course, we've done the most common, as you might guess. There are lots of other distributions, but we can't do it in this class. So this is the F distribution. Okay. And honestly, actually, I have no idea why they call the letter F. Maybe I should look it up someday. I never heard anyone say it. And different degrees of freedom change the shape a bit. If you have a whole lot of degrees of freedom, it's not that different from being normal. You never get negative numbers though. There's a square going on. I won't get into the math though. Okay, so that's the F distribution. And for ours, our test statistic was about 0.3339 or so. And our p-value is about 0.8, 0.8099, or zero point 0.8 is good enough. Okay, it does show, again, I made sure that you can see the picture. It shows the rejection region, for 0.1, 0.05, and 0.01. We're way over here. We're not even close to the rejection regions, no matter what your level of significance is. Okay, so here's what we can do. Okay. So we can write down the F again. Oops, F was 0.3339. And the p-value was 0.801. Okay, what do you think the conclusion is going to be when you have a p-value of 0.8? There's nothing new here. You better know what that tells you. Even if you didn't know what the level of significance is, but we did choose it to be 0.05. Yeah, you failed to reject. That's a huge p-value. Okay, so the conclusion is there is statistically insignificant evidence to conclude that at least two of the race's population mean distance from their nearest public library differ. Okay, so I'm going to say it again. I'm going to say certain words loudly. There is statistically insignificant evidence to conclude that at least two of the races' population mean distance from the nearest public library differ. Why did I say those words loud? Yep, you have to use them. So in the exam, if you don't use those words, then again, it'll sometimes be insignificant, sometimes it'll be significant. You have to use that wording. If you don't, use a lot of points. If you just use AI, for example, you're probably not listening to me right now anyway. Then it's not going to give you exactly this wording, but you have to use this wording to get to get good credit. Okay, if you don't use that wording, you lose a lot of points. Okay, and again, if it's not highlighted in red or whatever, that like races and distance from the nearest public library, that's going to be different from every example. But the rest of them is going to be the same. Sometimes it'll be significant, sometimes it'll be insignificant. Any questions on the wording that I require for the ANOVA conclusion? Any questions? Okay. ANOVA is used a lot. It's one of these where you wouldn't notice. Here's something. Why can't you just use the old test and you could say, do a hypothesis test for whites versus blacks to see if there's a difference? Then do a hypothesis test for white versus Hispanic, then do a hypothesis test for black versus other, then do a hypothesis test for black versus Hispanic, and then Hispanic versus other. And you could do each of those hypothesis tests, and if any of those are a reject the null hypothesis, then you say, ah, there must be a difference. At least two are different because you found two that were different. What's wrong with that? There's something wrong with it. Why do you have to use ANOVA? And it's not me being mean, by the way. There's something really wrong with it. Any thoughts? Okay. It's not about fulfilling those requirements or something. There's something specifically wrong with it. Okay, so let me tell you, because what I did is I compared white, Hispanic, white, other, black, Hispanic, black, other, Hispanic, other. It's a whole bunch of comparisons. If you have a 5% probability of a type, let's say they were all the same, but you had a 5% probability of a type 1 error for each of the pairs you did, then those are going to add up to a pretty big probability of a type 1 error. So even if they were all the same, you're probably going to end up with a type 1 error and you're all probably going to say they're not the same. So ANOVA kind of puts it all together so that you don't have that issue. Does that make some sense? Because if you do too many tests on a group, type 1 error is going to be very likely for at least one of them. And if all you have is one to be a type 1 error, then there's a good chance of a type 1 error. So that's why you have to do ANOVA instead. And ANOVA is one test. And again, I'm not going to get into the details of the math, but you can trust me. Sound good? Any questions at all about ANOVA, analysis of variance? And just let you know, in our class, they're all going to be similar. So once you've seen one example, all the rest is the same. They're not going to all be about race and distance from the nearest public library, but same idea. Any questions? Okay, if there aren't questions, okay. Just let you know the conclusion. This is what I want you to say, but I want you to know that sometimes you're going to read it a little differently. Sometimes other people will say there is statistically insignificant evidence to make a conclusion that race is a factor in the distance from the nearest public library. I don't want you to write it that way on the exam, but you're going to see it sometimes that way too. I want you to focus this way, and that way I can force you to do it this way. So if you write it this way, I'll take off a lot of points. Not because it's wrong, but because I'm telling you. Okay. But you'll read it this way sometimes, you'll read it the other way sometimes. So the secret word is thank you. And thank you, especially for those of you who have been coming to these webinars. It's wonderful. And since we're at the very end of this class, I want to thank you. And that is the secret word, THANK, new space, YOU. And that will be the secret word. And I want to mention something about secret words. And I'll be sending out an email probably tomorrow for those who have missed a secret word quiz or more than one. You have to have done all your secret word quizzes. Every one that's missed, you lose 5% of the total grade for missing the secret word quiz. So if you've missed a secret word quiz, then if you miss two, your whole course grade goes down by a whole grade level. So if you would have gotten a C, but you missed two secret words, that's a D, which is not passing. So just let you know that. At this point, other than this week, but this week, hopefully you've just listened to me. But at this point, the only way to get points for a missed secret word quiz is to rewatch or to watch the webinar that you miss a secret word on, write detailed notes, at least 5 pages, handwritten notes, not typed, handwritten notes, and then take a picture of them, and then email me your picture of your notes, and then I'll give you the credit, and then you don't lose your 5%. Got it? Should be handwritten, not typed. Sound good? Okay. And I will be sending out like an email for those who have missed any secret word quizzes. Um, anything but this week, because I don't know. I won't know this week until after Sunday, but don't miss this week. Okay. Any questions on ANOVA? Okay. I want to remind you that the big thing this week, I mean, other than ANOVA, but is going to be Project 2. So I want to mention kind of the most common suggestions I make, the most common things that people leave out or mistakes. Secret word quiz watch when we watch a recording because yeah, so if you watch the recording and you do the secret word quiz before the due date, which is always Sunday after the webinar was given, then you don't miss on the secret word quiz. You can also very easily go to your grade book and see which ones you've missed and which ones you've made. Does that make sense? So you just click on gradebook, grades, you can see it. And it'll show you if it's got a one, then you've got it. Doesn't have a one, then you didn't do it. Does that make sense? So if you did the secret word quiz, then it counted. Okay, if you did it and got it right, of course, which isn't hard if you know the secret word, you just type it in. So hopefully that makes sense. Yeah, so for this one, for example, of course, if you're right now watching, then you can just do it. You still got to do the secret word quiz, even if you watch live, you still have to type in the secret word in the secret word quiz, which takes 10 seconds or something, or maybe 30 if you're a slow typist. Okay, let me talk about some of the most common issues for the project. So first thing is make sure to state whether you're referring to the population mean difference or the sample mean difference whenever it's what you're referring to. Okay? Don't just say the mean. Make sure that you specifically talk about what you're talking about and make sure you write it right. So if it is about sample mean difference, don't write population mean difference. Okay? The next one, which is real common, is don't confuse the confidence level of confidence with the level of significance. Okay. Don't just say, hey, I used a 5% level of significance, so now I'm going to use a 95% level of confidence. Okay. Instead, for the confidence interval, for the confidence level, you should look at the 90% confidence interval, talk about how the client would react and how useful it would be. Then look at the 95% confidence level, a confidence interval. Talk about how the client would react, what decisions the client will make, and how useful it'll be. Then look at the 99% confidence level and look at the interval for the 99% confidence interval, how the client will react, and how useful that would be. And then think about, well, which is going to be better for the client based on that usefulness. And if it's 90%, that means there's a 10% chance of it being wrong. That the population mean difference could be outside of that. And how much is that going to hurt the client? What damage is going to be done? And that kind of stuff. Same thing with the 99%. That means a much smaller chance of it being wrong, but it's going to be a lot wider. So don't just talk in general. Don't just say it's wide. Make sure you talk about what the client is going to do about it, how that particular thing for your project is going to affect the client. Okay. And it's very easy to look at the three confidence intervals by just changing the level and look and look and look. Okay. All right. Another thing you should do is if instead of a 95% confidence interval, if you wanted a 99% interval with the same margin of error, how large a sample size would you need? Don't just state the number, explain how you came up with it. Okay, and there's some math involved. Okay, and that's something you might need help in, but make sure you do it. Talk about it. Okay, that's all about, again, the margin of error and the sample size level, and so there's a lot involved. Okay. Don't just state you're using a 5% level of significance based on the type 1 errors, period. Or don't just state, hey, I'm going to use a 5% level of significance so that type 1 and type 2 errors are are similar. Um, you should go into the detail of the ramifications to the client of type 1 and type 2 error and talk about which ramifications are worse. And from that, you decide whether to use a 1%, a 5%, or a 10% level of significance. Does that make sense? Because these are typical things that people make mistakes on. Don't write, do not just write, oh, a type 1 error means that you rejected the null hypothesis when it wasn't true. That's general. Talk about how it's going to hurt the client. Okay, don't just write it in generality. Make sure you talk about the client's needs. The entire project should be written for the client and the client's needs and the decision the client is going to make throughout. Okay? When you interpret the confidence interval, after you've decided whether you're using a 90, 95% or a 99%, state the decisions the client will make based on the lower bound. Okay, and why? And then state the decisions the client will make based on the upper bound. They could be different decisions because they might be far from each other, and that's going to be different things. Okay? So that's really important. It's all about the decisions the client is going to make. Okay? Those are the biggest mistakes people make, things that they leave out or they write it wrong. So it's really important that you get this part right. Any questions on these pieces of the project? I do want to remind you one more thing, and maybe I'll remind you by showing you because it's easy to do. Have to get to it. Okay, in your project, you have to use this, and you're going to use the two variable stats. You have to use this spreadsheet program, not some other thing. It has to be this spreadsheet program. You have to copy and paste the key pieces. So if you're using independent data, you're going to copy and paste J and K. Copy that and paste it right into your project. If you're using dependent, you're going to copy and paste N and O right into your project. Okay, that has to be done. You're allowed to copy and paste other things. If you're using dependent, don't even think about copying and pasting independent. Okay. And Q and R are not important for this project at all. Um, but definitely the dependent or independent. So either JK or NO, depending on which is relevant. You have to use this and not some other spreadsheet. It has to be this spreadsheet. You should copy and you should do a screenshot. Do a screenshot. It's much easier for me to read. And then the problem is if you don't do a screenshot, if you just do a link, sometimes the link doesn't work, and then it's a mess. So better is a screenshot. Hopefully, y'all know how to do screenshots. If not, just go to Google, type in how do I do a screenshot with, my computer, whatever computer that is, whether it's a, Microsoft or a Chromebook or an Apple, and then it'll show you how to do it. It doesn't even take a minute to do a screenshot, and you just pop it in, copy, paste. Does that make sense? Because then I could look to see if what you're writing about it better have the same numbers. You know what I mean? Like if you're using dependent data and you said your standard error was 9.3, then I know you weren't paying attention because it wasn't 9.3, it was 8.84 for this particular thing. Does that make sense? Okay. So that is all important. Any questions on that? Because that's another mistake a lot of people make is they forget to put in their statistics by Larry Green spreadsheet program. Okay. Or they use some other spreadsheet program, which you're not allowed to use. You have to use this one. And it's free, by the way, so I'm not making you pay any money. It's not hard to use, but you have to use it. Any questions on that? Okay. As I mentioned, this is a shorter webinar than usual, but again, I'm always happy to answer questions. I think I'm gonna be calling it a day. I want to remind you of things that are happening again. I've already reminded you once, but I want to double remind you because it's the last chance. And that is the last pieces that you have for your project, for your class, for this class, is you're going to have a chapter 13 assignment. Okay. You're going to have the secret word quiz for this webinar. You're going to have a discussion assignment. The discussion assignment is the easiest discussion assignment of the entire course. If you do it late, then I don't know what's wrong with you because it shouldn't take very long at all. I mean, it's not a time thing. It just means that you're just procrastinator. So make sure you do the discussion assignment by Thursday. Okay, might as well do it earlier. That's important. And then I recommend, like today or tomorrow would be best, it would be to send me your draft of your project so I can read it. Okay. And then I'll give you, usually a dozen or so, sometimes 10 comments. I don't comment on, every little tiny, tiny, tiny thing, but I comment on every big thing that needs to be changed. So if there's a little spelling error, I don't usually comment on that. But if you make a mistake, like you leave something out, or if you write something that's statistically incorrect, then I make a comment, or you should have explained what it meant to your client. That's important too. And make sure you have a client. Okay, make sure you have a name of the client. That's really important. Just say, oh, lots of people be interested in this. Here's a bunch of groups. No, who is your client? And say who it is. Does that make sense? So that is important. Okay, and then once I look at the project, I'll email it back, email me, I'll email you my comments. And at that point, I only look at the project once, but the tutors will look at it and they can look at it. You can also post questions you have in the project to discussion board. That's fine. Okay, there's also always a Q&A discussion board for other questions you might have. So besides that, the other so that'll be, by Sunday. Again, by Sunday you have to have submitted your project. I recommend a little earlier, but yeah, I can't force it. And then I'll probably grade it early next week. Sometimes it takes some time because projects are long and it's a lot of reading and a lot of typing for me. So it takes hours and hours for me to grade these projects. So hopefully I'll be able to, get them done within a couple days. Okay, often not day one, but by Wednesday for sure I'll have it done. By a week from Wednesday. So that's just a note. And then the week 12, the only requirement for week 12 is the exam. And that is it's the only assignment of this entire course that's due on a Wednesday. And that's because the course is kind of over after that. Okay. So the final exam has to be done by Wednesday. You're welcome to do it, you know, Sunday if you feel like it or whatever, if you work on the weekdays and you don't have time or something, but you know, and after Wednesday it's over, class is over. So at that point you can't do anything. I do want to remind you that the final exam is not worth any more than the rest of the exam, so it's not like your entire grade's going to change, but it's 10%. So it can change, a whole letter grade. But if you have a 40% in the class is over for you. You can't pass this class because there isn't enough. So the final exam unlocks this Wednesday. I heard from someone else actually, it's already unlocked. You can open it. But again, I'd strongly recommend do not touch the final exam until after you've done the chapter 13 assignment, because a big part of the final exam is the chapter 13 stuff. Yeah. So the question is the final exam an equal amount of all the chapters? Not quite. It has all the chapters, but it has a higher percent on chapter 13 because that you haven't been tested on yet. Does that make sense? Yeah, so it's a higher percent on chapter 13, but chapters 1 through 12 are, also covered. But it's definitely a higher percent on 13. So that's why I said make sure that you do the chapter 13 assignment before you take the final exam, or it'll go very badly for you. The written questions, those are chapter 13 because you've already had written chapters, questions on the rest of them. Okay, if that makes sense. Okay, good questions, very good questions. One of the whole points of webinar and especially coming live is that you can ask questions and I'll answer immediately. Okay, but really good questions. I want to mention something else that actually has nothing to do with your grade, but it could make a big difference, and a lot of students do this. Let's say that you're going to need help in statistics in 2 years from now. Okay, you're obviously not a student anymore of this class. I will be happy to help you out with statistics. And I'm going to let you know of the different my different rules. If you're, let's say you're getting a master's degree in psychology or something, and you're writing a thesis, and you're doing stats, and you forgot how to do something, or you want help, send me. I'll be happy to, take a look at it and give you some help on, on work that you're doing in advanced work. Does that make sense? If you're doing anything with education, I'm always happy to help out. And just send me an email. You won't be able to go to campus anymore because it closes, I think, a week after the class is over or something. But you can send me an email and I'll be happy to help. And I've helped a lot of people. Okay. And I'll do my best to help. Um, if it's for, let's say you have a business and you own the business or you're a manager of the business and you want some help in statistics, here's my deal is I will help you with that, but you're going to have to pay money, but not to me. I don't want your money. What I want you to do, and I do this a lot, is you have to donate money to a scholarship at our college. Doesn't have to be millions, but so that if it's for, your own financial business stuff, then I'll be happy to help with statistics, but I want you to donate. And I donate to a scholarship every year too, by the way. Just let you know that. But I do, maybe because I was a poor student and scholarships made all the difference for me. Otherwise, I went to graduate from college because I wouldn't have the money for it. Um, so I believe that if you have a business, you're making money, then give a little money instead of giving to me, give to a scholarship. Sound fair? And I'll be happy to help you with your business or whatever. Okay, I don't charge, but I want you to support students. Sound good? Always happy to do that. Okay. And you're always welcome to share my calculator or any of the stuff I've done with people. That's all open and free to everybody. Okay, those links won't change in the near future, at least. 20 years from now, who knows what'll happen, but but they've been around for a while. Okay, so that's pretty much it for the class. What I'm going to do, as always, I'm going to stop the recording, but thank you so much for, all your effort. I really hope all of you, finish this class well. There is no extra credit. Don't ask for, what can I do now to improve my grade with extra credit? There isn't. Okay, you could do well on the project, you can do well on the exam. I think it's chapter 13. Okay, and the discussion post is easy. Make sure you just don't do it late. You'll read it and you'll see it's the easiest. It's so super easy. There's no statistics to do. You'll see. Um, but I hope you do well, but there isn't going to be extra credit. So if you have a real low score, you could take it next quarter. And we have it every quarter, by the way. Hopefully you won't need to, but there's some of you that aren't doing as well. So I'm going to stop the recording and thank you so much.